Hello, my name is Assis, and this is my video presentation for BIT362 Digital Forensics Assessment 2. Now, on this assessment, we are going to look through different hashing techniques and how file change affects hash values. For part A, uh, I will test different changes to a file and compare the hash results. I will also use autopsy and Wireshark to do some of the questions. And for part two, I will demonstrate a new tool called Has My Files. So let's start. So the first question is to convert my student number to UMD5 hash. I've created a file here. I've kept all the evidence of my work so that it will be easier to demonstrate during this presentation, and I don't have to go through everything once again. So let's go to uh, command prompt. Okay, command prompt is here. I've got a, this is my student ID. Okay, let's copy this command. Okay, first of all, student.txt contains my student number, and I am going to generate the hash value of this file. So this is my hash value. I have already stored it here in this file to compare it with our results. So now, all right, there's one. Okay, where's my file? Okay, changing attributes, read only slash hidden. Okay, so now in here, let's change the attributes of this file. Um, Properties. Okay, let's make this read only and then do the same thing. CMD swap. Okay. So as you can see, the hash file value is exactly the same. So we found out that the changing the attributes of a file does not affect the hash value at all. I've also noted all the results in here as well. So now we'll change the permission. So when we change the permission of the file, okay, let's go here, properties, advanced, security, let's do administration edit. So let's deny the permission, okay. Cancel, go to command prompt again, same. Now the hash value is exactly same this time as well. So no changes to hash value, um, which has been documented already because I've done all this process before recording the video. So hash did not change, read only changes the metadata and not content. So the attribute for changing the permission um, does not change the file content, so the hash value remains the same. Changing the extension. Okay. Uh, s- s- mm, this one and rename this one. Let's say let's make it EXE. It's fine. Uh, this file is already open on. Okay, however, I've already done that before, and then I have the screenshot here as well. So extension test here. When I change the extension, the hash file remained the same. This is already been confirmed by this screenshot. So we're just gonna skip that one. Uh, and what's next? An email. Okay. So okay, I've done this one as well. So just as an evidence, let's go to my email. So as we can see here, I've emailed the file myself multiple times, and I've downloaded the file and I've done the I've generated a hash of that file as well, just to check. Should be in here as an evidence email again. This is the evidence where I sent the email and the hash result. So again, even when I downloaded the file and generated the hash of the file, it remained exactly the same as before. Because emailing, when we email some file, it does not change the content of the file. The file remains the same, so the hash values remain the same as well. Okay, we can close this one. Let's move to not Wireshark, not yet. Let's move to append the file with spaces. Okay, now this is a very good one. So let's open this string.txt and let's add some spaces in here. And then mm, s- close this one. Let's, oh, already have my command prompt here. Stop this one here. Okay, now we can see, sorry, I didn't think I saved the file. So let's open this one. Okay. Yes, replace it. Let's revert back the permission. Okay. Mhm. Security. Uh, this permission. Let's go to command prompt. Uh, so what is this one? File. Stay. Okay. Okay. Let's go to command prompt once again. Type in the value. As you can see, when we added some space in there, the hash value changed. Um, Now, okay. When I added the spaces to the file, the hash changed completely in here. This is because space are part of the file data. So when a content of the file changes, even a small change will trigger will produce a very different hash value. So that's the reason why the hash changes. Um, Now we're gonna remove the spaces from there. Let's open this once again and remove these spaces as is completely as before. So okay, this has been same. I already have my command from here. Let's run this in. Now the value reverted back to the original one. Since the data is exactly the same, the hash value is going to be um exactly the same as well. Okay. Let's move on from here. Let's what's works name is okay. Mm, okay, so now I'm going to open autopsy and I will so I just want to show here I have imported for this question. I generated the MD5 as the student.txt file, as we can see, and I added it into autopsy as a notable hash set. I'll show it here quickly. So it has been stored as student.hash. I have imported it to autopsy, and then I ran the hash lookup in this module. And then when I ran that one, let me show you the file. It came in here as student.txt. So autopsy detected one hash set hit. Uh, Here, okay, hash set hit as student hash. Um, and flagged student.txt. So this shows that autopsy searched for the file using the hash value and not the name. Um, so the so the hash is calculated from the content of a file and not from the file name. Therefore, autopsy searches based on the file content and not simply just the file name. This means even if a file is renamed or the same content is used in different file, we can still identify it using the hash value. So this is done as well. Now moving on to question number 7. Sorry, this is not the right one. Question number 7. Um, and using a reverse EMD5. So EMD5 is a one-way hashing algorithm. That means we can generate a EMD5 hash of a file, but we cannot revert it back unless the file is already on the database. So just to prove that one, I've got this hash decoder website. I'm just gonna put in my hash value in here, and I'm gonna try to revert it back to my original student number. So let's quickly copy my hash of my student.txt file, change this to emd5. Okay, let's keep going. I guess using time in here. Mm, let's wait for a few minutes. Yeah, as you can see, name has found. Until and unless we've got a database which already has our original file, then only it can detect. So MD5, reverse MD5 tools like this don't truly reverse or decrypt the hash. They just compare the hash in the database that they have. And if they find any values that already exist on the database, then they'll show us that. But obviously, our student number is not on the database, so it did not show up. So we can close this one up. So next up, we'll move to Wireshark. So while I was emailing myself all the file, I captured these packets of data. Um, so Wireshark captured all the packets over time while all the activities are occurring on the network. Yeah. Um, so this was the communication is not sent as a single item. Instead, we've got number of packets in here, and these packets will show us information about the protocols used to transfer the data, the source address, and the destination address. Um, and the packet length as well. So that's our Wireshark capture. Now for part B, I've installed a tool called Hash My File, which is used to generate different hash codes of a file. Let's move into there. Let's move into there now. Okay. Mm, should be in here. So this is the zip file. Let's gonna run this one. Now I'm going to mm, generate the hash of my string.txt file. As you can see, this not only generates the MD5 hash, but this only generate these this tool also generates other hashes as well. So there's SHA1, CR C32, SHA256, and things like that. And we can see other information about the files as well in here. So we can not only select just one file, we can select a whole folder and do that thing in here as well. uh, these hashes are based on the content of the file, obviously. Mm, Hash my file can also calculate hashes for multiple files at once, as I said. It can detect duplicate file. So if like two same files are created using different names, but the hash value is going to be same because the content is same, and it will detect and remove the duplicate files as well. We can export these results into formats such as the a CSV, HTML, or a text file as well. This makes it very useful tool for forensic documentation and evidence verification. Okay, in so to sum up all of this, this assignment was very helpful for me to understand how hashing works in real life and what are the things that I can do um, using autopsy, and what sort of data does the Wireshark captures. Um, so when metadata changes, such as the file attributes, the permission, the extensions, the hash did not change. because the content of the file did not change and the hash is dependent on the content of file. But when we added some space, the hash file changed because obviously the content of the file did change. Um, the autopsy has lookup so that the forensic tools usually identify files based on the content hashes rather than the file names. Overall, hashing is a very important forensic technique because it helps to detect file modification, verify data integrity, um, and it also supports a trustworthy and a reliable digital investigation. Thank you.